Hello students, today now we will be continue with our chapter some basic concepts of chemistry. In the last lecture we have completed up to the states of matter, that is the properties of solid, liquid and gaseous state. So today we will see properties of matter and their measurement. Physical properties and chemical properties. Physical properties are those which can be measured or observed without changing the chemical composition of the substance. Example: color, odor, melting point, boiling point, density, etc. are physical properties. So, when you are measuring the physical property, the chemical composition of the substance will remain the same. This is the very important point, that without changing chemical composition, we are observing, we are measuring that properties called the physical properties. Then what are the chemical properties? Chemical properties are the properties where substances undergo a chemical change and thereby exhibit change in chemical composition. यहाँ chemical composition will be changed. So, chemical properties, substance undergo chemical change. Example: coal burns in air to produce carbon dioxide, C plus O2 giving CO2, or magnesium wire burns in air in the presence of oxygen to form magnesium oxide, magnesium Mg plus O2, 2 Mg plus O2, that is 2 MgO, magnesium oxide. So, chemical properties means what? There is a chemical change in composition, two substances react with each other and there is a formation of product. So, these are the chemical properties. Chemical properties involves the chemical reaction, and physical property, there only you are going to, without changing the chemical composition, you are observing that particular property. Measurement of properties. Many properties of matter such as mass, length, area, pressure, volume, time, etc. are quantitative in nature. Quantitative in nature means you have to take the measurement and you have to write it according to the unit what you are using that for purpose. Length is suppose 5 meter, mass 25 kg, areas 25 centimeter square. Like this you have to use the, that is the unit. Any quantitative measurement is expressed by number followed by units in which it is measured. That is called the magnitude. Suppose you are measuring the length, and if you tell that the length is 25 centimeters, means 25 is the magnitude and centimeter is its unit. So, any quantitative measurement is always expressed by one number, and number that is called the magnitude, and then it is followed by the unit in which it is measured. Example: length of classroom can be represented as 10 meter. Here 10 is the number, that is magnitude, and m denotes the meter, the unit in which the length is measured. The standards are arbitrarily with some universally accepted criteria. The arbitrarily decided and universally accepted standard are called the units. So, this is the definition of unit. The arbitrarily decided and universally accepted. See, this is very much important, that the whenever you decide the unit should be accepted by all over the nations. The arbitrarily decided and universally accepted standards are called the units. There are several systems in which units are expressed, such as CGS. What is meant by the CGS? Centimeter for length, gram for mass, and second for time. Then second in FPS system, foot pound second, and third MKS meter kilogram second system. So these are the different systems of unit: CGS, FPS, and MKS. So the arbitrarily decided and universally accepted standards are called the units. Then we will see what is mean by the SI units, Standard International Units. In 1960, the General Conference of Weights and Measure proposed revised metric system called International System of Units, that is called SI units. The SI system has 7 basic units. They are called the fundamental units. So in 1960, these SI units are formed, and from that there are 7 basic units are there, and they are called the fundamental units. Now we will see which are the 7 fundamental units: length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. So first we will see the length. Symbol is small l. Name of SI unit meter, METRE, and symbol is small m. Mass, symbol small m. Name of SI unit kilogram, kg, symbol. Time t, second, small s. Electric current I, ampere, capital A. Thermodynamic temperature T, unit Kelvin, symbol K. Amount of substance small n, mole, and symbol MOL. And luminous intensity I, that is candela, symbol is CD. So these are the 7 basic fundamental units, symbol, and name of that SI unit. Base quantity, length, it can be simple as LHR, that is length, height, radius. Mass, small m. Time, small t. Electric current, either capital I, small I. Temperature T. Amount of substance N. Luminous intensity IV. Name meter, kilogram, second, ampere, Kelvin, mole, candela. And symbol for length small m, for mass kg, time s, electric current ampere capital A, temperature Kelvin, amount of substance mole, and luminous intensity CD. Physical properties. First, mass and weight. We know that matter has mass, so mass is an inherent property of matter. It is the measure of quantity of matter a body contains. What is meant by the mass? Mass means quantity of matter the body contains. The mass of a body does not vary as its position changes. It remains same. Suppose one table is there or one substance is there, it has a weight of 5 kg. Wherever space, place or time, it does not change, it remains same, that is the 5 kg. So mass of a body does not vary according to its position changes. On the other hand, the weight of body is the result of mass and gravitational attraction. But weight means what? Weight means mass into gravitational attraction, that is G, that is the universal gravitational constant. G is acceleration due to gravity. So what is difference in mass and weight? The weight of a body varies because gravitational attraction of the earth for a body varies with the distance from center of earth. See, you have to remember one thing clear, that mass does not change. Mass remains same anywhere they are present on the earth, but weight may be changed because of the gravitational attraction of earth for different places is different. So it is depend upon the distance from the center of the earth. If you are in the at the on the moon, your gravitational attraction is very less, and that time your weight will be changes. So on earth your weight will be different. So weight is different, mass remains same. Hence mass of a body is more fundamental property than its weight, because mass does not change, weight can be changed according to the pace. The basic unit of mass in the SI system is the kilogram. However, a fractional quantity gram is used for weighing small quantity of chemicals in the laboratory. Therefore, in terms of gram, it is defined as 1 kg is equal to 1000 gram or 10 raised to 3 gram. This is the conversion unit, kg into gram. So this is about mass and weight. Then we will see volume. You already seen that the matter has a two important property. It has a mass and it occupies the volume. It is the amount of space occupied by three-dimensional object. What is the volume? Amount of space occupied by three-dimensional object. It does not depend on shape. For measurement of volume of liquid and gases, a common unit is liter, which is not an SI unit. 1 liter is equal to 1 decimeter cube is equal to 1000 milliliter, 1000 centimeter cube. 1000 centimeter cube is equal to 10 centimeter into 10 centimeter into 10 centimeter of volume. So SI unit of volume is meter cube. Meter into meter into meter, that is meter cube, or centimeter into centimeter, that is centimeter cube. So volume is what? It is a amount of space occupied by three-dimensional object, and it does not depend upon the shape, and its unit is liter or decimeter cube or milliliter. See, there one diagram is there. It shows that the volume is 1000 centimeter, 1000 milliliter, 1 decimeter cube, 1 liter. All this is having same. 1 liter is equal to 1 decimeter cube is equal to 1000 milliliter is equal to 1000 centimeter cube. So there is a cube which shows the length, height, breadth, that is the 1 centimeter. Different kinds of glassware are used to measure the volume of liquids and solution. For example, graduated cylinder, it has a marking 10 ml, 20 ml up to 100. Pipette, which is maybe having a 10 ml or 25 ml. Burette for 50 ml. Volumetric flask, maybe of 100 ml to 50 ml. It is used to prepare a known volume of solution. Generally in laboratory, you see these glasswares which is used to measure the volume of the liquids and solution. Then we will see what is with the density. Density of a substance is its mass per unit volume. It is determined in the laboratory by measuring both the mass and the volume of sample. If you have to find the density, you have to first find the mass and volume. The density is calculated by dividing mass by volume. Mass should be divided by volume, then you will get the density. Characteristic property, it is one of the characteristics property of substance. So SI unit of density can be obtained as follows. See how they are calculated the SI unit of density. SI unit of density is equal to SI unit of mass divided by SI unit of volume. So what is the SI unit of mass? Kg. And SI unit of volume, meter cube. Kg upon meter cube, that is kg per meter cube. And in CGS, instead of kg you have to use gram, and instead of meter cube you have to use a milliliter. So gram per liter or gram per centimeter cube. So this is the SI unit of the density. So density is one of the characteristic property of any substance, and it is formula is mass per unit volume, that is mass divided by volume. Then one of the most important property that you are measuring, temperature. Temperature का see the definition, temperature is a measure of hotness or coldness of object. If you have to measure hotness or coldness, you are using the temperature. There are three common scales to measure the temperature: degree Celsius, degree Fahrenheit, and Kelvin. K is the SI unit. From this, Kelvin is SI unit. So temperature means what? Hotness or coldness of object. There are three common scales: degree Celsius, degree Fahrenheit, and Kelvin. And from that, Kelvin is SI unit. This figure shows the temperature thermometer based on these scales. Generally, the thermometer with Celsius scale are calibrated from 0 degree to 100 degree, where these two temperatures are respectively the freezing point and boiling point of water. 0 degree Celsius is freezing point of water and 100 degree Celsius is boiling point of water at atmospheric pressure. These are represented on Fahrenheit scale as 32 degree Fahrenheit to 212 degree Fahrenheit. So there are three scales Fahrenheit. First it shows the Kelvin, second degree Celsius, and third Fahrenheit. So these are the three important basic scales of temperature. Now we'll see the formula for conversion of degree Celsius into degree Fahrenheit. Degree Fahrenheit is equal to 9 upon 5 degree Celsius plus 32. And how to convert degree Celsius into Kelvin? Just you have to add 273.15. Suppose 25 degree Celsius and you have to convert it into Kelvin. 25 plus 273.15 you have to add, then it gets converted into the Kelvin scale. So these two formulas are very important to convert degree Celsius into Fahrenheit and degree Celsius into Kelvin. See these two formula: Celsius to Fahrenheit, F is equal to 9 upon 5 C plus 32, and Fahrenheit to Celsius, C is equal to 5 upon 9 in bracket F minus 32. So these are the conversion formula: Fahrenheit into Celsius, Celsius into Fahrenheit. Now we'll see one numerical on this. Convert Celsius to Fahrenheit. F is equal to 1.8 C plus 32. If suppose degree Celsius is 37, so you have to substitute 37 at the place of C. So F is equal to 1.8 into 37 plus 32. That is F is equal to 66.6 plus 32. That is 98.6 degree. So degree Celsius, 37 degree Celsius means what? 98.6 degree Fahrenheit. So this is the conversion of degree Celsius into Fahrenheit. So this formula converts the Celsius to Fahrenheit. Then in the next example we see how to convert Celsius to Fahrenheit. F is equal to 9 upon 5 C plus 32. Now here F is equal to 9.5 into 50. Degree Celsius say 50 plus 32. So 9 upon 5 into 50 upon 1, that is 90 plus 32. So 90 plus 32 means 122 degree Celsius. So Fahrenheit degree Celsius is converted into Fahrenheit by the formula C is equal to F is equal to 9.5 C plus 32. Convert 50 degree to Celsius to degree Fahrenheit. So these are the two important formulae for the conversion. So in this lecture we have completed up to the main physical and chemical properties of the substance, and how to measure, what are their units, what are the fundamental units, and conversion of Fahrenheit into degree and degree into Fahrenheit. So in the next lecture we will continue with laws of chemical combination. So there are different 4 to 5 types of laws are there of chemical combination. So we will take that laws in the next lecture. Thank you.